Booyah, peeps. All right, so this is the 7th video on factoring polynomials from 5.5 to 5.7. This concept is in 5.7. And we're talking about two-term polynomials that are defined as a difference of squares and how we're going to factor them. Remember that squares just mean that I can get something times itself. Okay, and in this case, I would have a times b, a times a, and b times b. And then, of course, difference means this cute little sign here. The way we say difference is the same thing as subtract in algebra. You know, it's like learning the language. Okay, so my first step, always is going to be to check for a GCF or factor it out. So 81 and 16. This is 9 times 9 and 4 times 4. There's no common factors here, so I have no GCF. But I am going to factor these down. I'm going to say this is a two-term polynomial with a minus sign. Okay, so I'm going to check to see if this is a perfect square. Well, this is 9 times 9, and this is y times y. Okay, well, it looks to me like it's a perfect square because it's the same thing times the same thing equals 81y. And this is a perfect square. And if those are my perfect squares, then this is a difference of squares. And what I'm going to do is this is going to factor to a plus b, a minus b. Well, in this case, a is 9y, and b is 4. And this is just going to be a plus minus. Now again, I get a lot of people saying, well, what if I did it minus plus? That's totally fine. Doesn't matter what order those go in, as long as one is positive and one is negative. And the reason why is because when you multiply this back out, if I multiplied 9y minus 4 and 9y plus 4, remember we talked about this. These two terms right here are called conjugates. It's the same two terms with opposite signs. This is going to come up later. Okay, well, when you multiply conjugates, when we FOIL these, we get 81y squared plus a 36y minus a 36y minus a 16. And you can see here that these middle terms always sum to 0. And that's how you get a two-term perfect square polynomial that is a difference of squares. Okay, so that's what that one looks like. Looking at this next one, I'm going to check it for a GCF. 49, factors of 49 are 7 times 7, and factors of 100 are 10 times 10. Those don't have anything in common, so I'm going to break them down and say this is a two-term polynomial with a difference sign here, so I can factor this, and I'm going to see if these are perfect squares. Well, this is a perfect square and the root is 7x, and this is a perfect square and the root is 10y. So that's going to go in each of these factors here, a 7x plus a 10y and a 7x minus. Someday I'm going to not write so sloppy. Minus a 10y. It's going to be plus minus again. They just have to have opposite signs for those middle terms to drop out, and that's why we don't have a middle term here. So this is factoring this difference of squares. So looking down here at this next one, I'm going to have a 2w squared and a 128. Well, first thing I'm going to do always is factor out a GCF. They have a 2 in common and they have a w squared in common. So I'm going to factor out this 2w squared. And when I do, 2w squared divided by 2w squared is just a 1. And then I'm going to get a minus, oh, this is supposed to be to the fourth, guys, minus a 64w squared. I just wrote the wrong number right here, so make sure you change that. So 128 divided by 2 is 64, and w to the fourth divided by w squared is w squared. Okay, it doesn't matter what comes first or second. 1 is a perfect square, and after I've factored out the GCF, again, I'm going to not look at it. I'm looking inside of right here. Well, 1 is a perfect square. It's 1 times 1. And 64, w squared is 8w times an 8w. So that is a perfect square, these both are, and this is a subtraction sign. So this is indeed a difference of squares, so this can factor further. So that is going to factor to a 1 plus, get ahead of myself here, 1 plus 8w and a 1 minus 8w, but I can't forget that I need to bring down this 2w squared, and this is factored completely. Also want to point out that this again is just a general form. I could have something bigger than a squared here. I could have a fourth, just like we did here, or a sixth, or whatever the case is. But I'm going to say, is there a GCF in this last one here? 9 and 25 have no common factors. There's no x here, so there's no GCF. So I'm going to say this is a difference. Checking it out. It's a two-term polynomial, it's a difference, but are these perfect squares? Well, the root here is going to be 3x squared, because 3 times 3 is 9, and x squared times s squared is x to the fourth, and the root here is going to be 5. So yep, this checks out. This is a difference of squares. So I'm going to get a 3x squared plus 5 and a 3x squared minus 5. Okay, so we haven't gotten to this point where, like I said, we're going to check for nesting, but we have now gone through every possibility of that you might see on the exam, counting the number of terms and then going through each concept or method for factoring those. So I'm not going to cover, I'll do different videos for sum of cubes and difference of cubes, and another video for putting all this together, and we'll talk about nesting in that video. So this is the end of 5.7.